welcome to my YouTube channel, and today we are going to learn something new. This video will be all about subtraction of rational expression, part 4 of our lesson. Subtracting similar rational expression is like the one used in arithmetic action. Only similar rational expressions can be readily combined. What we want to do is to subtract the numerators, then place the result over the common denominator. In symbols, it's going to be a over d minus c over d is equal to a minus c over d. And let's have our first example. Subtract negative 10 minus 6x minus 5x squared over 3x squared plus x minus 2 from x squared plus 5x minus 20 over 3x squared plus x minus 2. Let's solve. Arranging the given, we have x squared plus 5x minus 20 over 3x squared plus x minus 2 minus negative 10 minus 6x minus 5x squared over 3x squared plus x minus 2. Since our given, of course, is similar rational expression, we have to combine the numerators. In grouping together, we have the quantity of x squared plus 5x minus 20 minus the quantity of negative 10 minus 6x minus 5x squared, that is our numerators, over 3x squared plus x minus 2. Let's remove the parentheses. That will become x squared plus 5x minus 20 plus 10 plus 6x plus 5x squared. Now let's combine like terms. When we say like terms, these are terms whose variables and exponents are the same. So from the above calculation, our like terms are x squared plus 5x squared, 5x plus 6x, and negative 20 plus 10. Let's continue with our solution, rewriting the previous calculation that we have. X squared plus 5x squared plus a quantity of 5x plus 6x plus a quantity of negative 20 plus 10. Solving this one, we have x squared plus 5x squared is equal to 6x squared. 5x plus 6x is equal to 11x, and negative 20 plus 10 is equal to negative 10. So this is now our answer. But this is not yet in its simplified form, so we have to apply factoring to simplify this one, and this is the process. And finding the factors, you have to do trial and error and applying the FOIL method. factors of 3x squared plus 11x minus 10, we have the quantity of 3x minus 2 times the quantity of 2x plus 5 over the factors of 3x squared plus x minus 2. We have the quantity of 3x minus 2 times the quantity of x plus 1. Cancelling out the common factors, we have 3x minus 2 and 3x minus 2. Cancel that one out, and our answer is 2x plus 5 over x plus 1. So this is now our final answer. Move on to subtracting the similar rational expression. And again, this is the same with addition, and we are still going to use the least common denominator. For our second example, we have subtract 80 minus 24 over 9 minus t squared from t plus 3 over t squared minus 6t plus 9. Arranging the given, we have t plus 3 over t squared minus 6t plus 9 minus 8t minus 24 over 9 minus t squared. Making the given into a similar fraction, this will be a bit tricky. And what we're going to do is, of course, we have to factor out the denominators first so we can see what are the LCD. Our first denominator, which is t squared minus 6t plus 9, is an example of a perfect square trinomial, so it is easy for us to factor out. The answer is the quantity of t minus 3 squared. And for our second denominator, 9 minus t squared, we have to rearrange this one so that we can see directly what are our factors. And rewriting this one, we will make this into its equivalent expression, which is the quantity of negative 1 times the quantity of t squared minus 9. Since we have to determine the sign for our fraction, take note that the operation now can be changed into addition, since a negative 1 can be multiplied to the operation. So negative times negative is equal to positive, and then we'll go ahead and find the LCD once we identify the sign. Next, we are finding the LCD to make our expression similar. Take note that we can directly see what are the common denominators, and that is the quantity of t minus 3 squared and the quantity of t plus 3. So these are the two common denominators that we have. If you can recall the process of finding the LCD for fractions, I have here an example so that you have an idea as to how we got the calculation. My example is 7 over 5 plus 1 over 3. Note that the LCD of our denominators is 15, and we'll go ahead and make it into a similar fraction. 15 divided by 5 is equal to 3 times 7. We have the answer is 21. 15 divided by 3 is equal to 5 times 1 is equal to 5. And then 21 plus 5 is equal to 26 over 15. So this is now our similar fraction or answer. And applying it to rational expression, we have squared minus b squared minus 2 over a plus b. For our solution, the first thing that we have to do is to factor the subtraction first, so we can identify our LCD. A squared minus b squared can be factored out as the quantity of a minus b times the quantity of a plus b. This is an example of a differential square. Rewriting our expression, after finding the LCD, we have 3 minus 2 times the quantity of a minus b. With our LCD is a minus b, a plus b. And then simplifying it, we have 3 minus 2a plus 2b over